In decimal, 1 plus 1 is considered as value 2. The last digit 0 is called the sum bit and this 1 is called the carry bit. Hello everyone, welcome to my channel Sai Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more interesting videos. In today's video, we are going to discuss about 1's and 2's complement. Already we had been discussing in the binary arithmetic playlist binary addition, subtraction, multiplication and so on. And now we are going to discuss about 1's and 2's complement. This can be done in 4 simple steps. In the first step, you want to know about how to convert a simple binary number to a 1's complement. In step 2, you want to know about how to convert a binary number to 2's complement. In step 3, you want to know about simple binary additional rules, which will be helpful in solving 2's complement. In step 4, now you can able to solve all these examples. Here I have been discussing, we have planned to discuss 5 examples from a simple binary number to a complicated binary number which has more than 7 or 8 digits and which has more number of carry bits. So watch the video fully for getting a very clear idea and solving a complicated binary digit also. Okay, now let's move on to our video. Consider this example 01001011, a binary number. The base idea to convert a binary number to a 1's complement is you have to replace all the zeros with ones and ones with zeros. This seems to be a very simple concept. Consider this number 01001011. This is the binary number. Now we will be replacing all those zeros with ones and ones with zeros. Here the 1's complement number, that is for 0 1 and for 1 0. It is considered or it is written as 10110100. Now the base idea for converting to 2's complement. From a given binary number, we have to first convert it into a 1's complement number, that is replacing zeros and ones. Zeros with ones and ones with zeros. Now for 2's complement, first convert to 1's complement and then at the last binary digit you have to add a 1. After adding 1, the resultant bit will be the 2's complement. So consider in the same example, here we have converted from a binary number to 1's complement. Hope you would be very clear since it is a very basic concept. I need not go in depth about the 1's complement. You can solve on your own. Now consider this 1's complement. This is the binary 1's complement. For converting to 2's complement, we are just adding a 1 to the last binary digit. So 0 plus 1, which is 1. The other digits are represented as it is 0, 1, 0, 1, 1, 0, 1. Everything is represented as it is. So this is the resultant 2's complement. Now you have got the base idea from this example. This is a very simple binary number. Now before moving on to example 2, you want to know about the simple binary additional rules. Here we have 4 rules. The first 3 rules are as common as a decimal addition rules, that is 0 plus 0 equals 0, 0 plus 1 equal to 1, 1 plus 0 equal to 1, everything is common. We have to consider the last rule, that is 1 plus 1 equal to 1 0. I had already discussed about the binary addition in my previous video. If you want to know more or in depth about the binary addition, check my previous video. The link will be given in the I button. Okay. Now I am briefly telling you about the fourth rule so that you can be able to solve the 2's complement with the carry bit. So 1 plus 1 equal to 10 it is given. In decimal 1 plus 1 is considered as value 2. For the decimal value 2, the concerned binary value is 10. It is a very simple concept only. 10. So in the 10 also, the 0, the last digit 0 is called the sum bit and this 1 is called the carry bit. When we are solving the example, you will be very clear about this concept. Consider this binary number. In example 2, the given binary is 00110110. This is the given binary number. Now you want to find the 2's complement for this number. So the base idea is we have to convert first into a 1's complement and we have to add a 1 at the last binary digit. So the 1's complement is converted. Consider 0011, again 11 it is 00. Similarly for all the digits, the 1's and 0's are replaced. Now in adding 1 plus 1, that is the last digit we are adding. So 1 plus 1, as per the fourth rule, it is given as 10. Its decimal value is 2 and since we are doing binary addition, it should be represented as 10 only. This 0 as sum bit. Here it is represented, the last digit 0 as sum bit and 1 as carry bit. So this 0 as sum bit and this 1 as a carry bit. This is called the sum bit and this is called the carry bit. So for your clear representation, I had represented in the red color. You can check it out. So 0, 1 is carried out. Now 1 plus 0, 1. Again, there is no addition is carried out. So the same numbers can be repeated as it is 1 1 0 0 1 0. Here 1 0. Okay. You would be now clear. Here we are having only a 1 carry. The first addition does not have any carry. Here we are having only 1 carry. Now consider example number 3. Here the given binary number is 0110000. First step, we want to convert to 1's complement. It is converted as 1001111. And for converting to 2's complement, a 1 is added at the last binary digit. So 1 plus 1, which gives 10, 0 as sum bit and 1 as carry bit. So all these ones represented in red color represents the carry bit. So 1 plus 1, 0 here. A 1 is carried out to the next digit, next binary digit. Again 1 plus 1, again 1 0. So 0 in sum bit, the 1 is carried. Again 1 plus 1, again a 0. Again 1 plus 1, again a 0. Again a 1 plus 0. Here 1 plus 1 0, the carry 1 and here 1 plus 0. So 1 is represented. Again this 1 0 is written as it is since there is no numbers to add here. So the final value is 10100000. You will be more clear when after solving the fourth example and fifth example, which also has more number of carry bits. For your exam point of view, I had given here of binary digits 7 to 8 binary digits having more number of carries, so that any complicated binary digit, if it is given for your exam also, you can be able to solve. So watch carefully. So now the binary value is 1010000. When converted to 1's complement, 01011110000 replaced by 111111. And here in the last binary digit we are going to add for converting to 2's complement. So first complement number when added with 1 gives a 2's complement number. This is the base idea. So 1 plus 1, which gives 10. So 0 here, Yeah, 1 is represented here in the next binary digit. So 1 plus 1 again 0. 1 in the carry bit. Again 1 plus 1 0 in the sum bit. 1 in the carry bit. Again 1 plus 1 0 in the sum bit. Again 1 in the carry bit. So now 1 plus 0 which gives 1. This 0 1 is repeated as it is. So the given 2's complement number is 0, 1 1, 0 0, 0. In the first example, I had represented that this is the 1's complement and the sum value is 2's complement. Here you can, hope you can understand. I didn't represent it in each of the example that this is 1, this is 2's complement. So just you can follow one. And then in the final example, 00 which consists of 8 binary digits, 00, 11, 00, 00. So when converting to 1's complement which gives 11, 00, 11, 11. This is the 1's complement number. And when we are adding another one which gives the 2's complement number. So 1 plus 1 which decimal value is 2. When represented in binary it is 1 0. And in 1 0 also always the 0 is represented as sum bit and 1 as a carry bit. This rule you should remember compulsorily for solving this problem. So 1 plus 1 0. Yeah, 1 is carried over. Again 1 plus 1 0. Again 1 is carried over here. 1 plus 1 0. Again 1 carried over. 1 plus 1 0. Again 1 carried over. So now 1 plus 0 which gives 1. Again all the numbers are repeated as it is. Now the numbers are written in black color and the carry bits are represented in red color. Okay. Now the final number arrived. The 2's complement number is 11, 01, 00, 00. So just a small recap. Here we are given a binary number. When you want to find a 1's complement number, just change the zeros to 1's and 1's to zeros. Very simple idea. That is the 1's complement. And when converting to 2's complement, you have to add the 1 to the 1's complement number. Don't forget this rule. Don't add the number to the binary number. You have to convert to 1's complement and then you have to add it. And this is the final 2's complement number. Suppose when we are having a carry bit here, 1 plus 1, remember this fourth rule, 1 plus 1 will give 0, that is 1 0. This 0 is always a sum bit and 1 is always a carry bit. The process continues until it reaches a single digit, that is 1 plus 1 0. Here there is no carry, so the numbers can be repeated as it is. Okay, that's all for today's video. If you find this video is very useful, then make a small comment about the feedback or feedback about this video in the comment section. Share this video with your friends. Keep supporting Sai Suriyas Academy. Thank you.